Hello and welcome to Old School Chemistry. Today we're going to do the ALEKS topic, distinguishing solid, liquid, and gas phases of a pure substance. I'm going to teach you how I teach my students. The first thing that I want you to do is draw a number line. On this number line, we're going to write down the melting point and the boiling point. Melting point, you know, is changing phase from the solid to the liquid. Here they tell us for carbon monoxide that is negative 205 degrees C. Now the boiling point, changing from liquid to solid, is negative 192 degrees C. Now above this, just to make it easy for us, I'm going to write down our phases on the number line. We've got solid, liquid, and gas. Next, they are giving us 3 samples, and we need to figure out what phase those are. Let me scroll up for us here. Okay, so our phases are negative 209. Oh, negative 209, that's colder than the melting point. That means that A is the solid phase. And then we have a negative 177, falls right in between our melting point and boiling point. That means B is going to be our liquid. And then we have a oh, I put that in the wrong spot. Sorry. Oh, and do you know what? I'm so glad that happened. This is a good reason why I tell my students to use a number line. We're dealing with negatives, and you have to be careful. Sometimes they get mixed up like I just did in your head. Look at this, negative 177, that's a gas. So that means B is the gas. I apologize for that. I'm glad you saw the mistake, so you won't make the mistake. And then we have the negative 202. There we go. That's in between our melting point and our boiling point. Okay, so we've got C is going to be the liquid. All right, remember the two things that you look at that distinguish, if you could see at the atomic level, the phases. It's first going to be how organized. Remember, solids are extremely organized. Gases and liquids are not organized. And then you're asking how compact each of these are. Solids are very compact, liquids are slightly compact, and our gases aren't compact at all. I call them maniacs. They're all over the place. So let's look at A here. I have a slider bar. So as we slide, you can see I move over, and those look far apart. That is actually a gas. That's actually a gas. Then, oh, look at this. Very organized, very compact. What is that? That's our solid. That's the answer. I do want to show you the other distractors, though. Interesting. Very organized and very compact, but that's wrong. Here's the reason why. This is carbon monoxide. I have 2 different elements. The way that we represent this as a pictorial view, as if we could see the atoms, is by doing different color circles, and we make them touch, the 2 elements touch, to indicate that they're bonded. It's a compound. So I'd have to say, let's say that carbon is the purple circle, oxygen is the blue circle. Those have to be touching to indicate a bond. They are a compound, carbon monoxide. Here, they're all separated. They're individual carbons and oxygens. So I very lovingly call that garbage. That is a nothing answer. And then we have another garbage. We have separated oxygen and carbon. It's not the compound carbon monoxide. And our last one, that's showing a liquid. So we have some space, a little bit of space, and disorganization. Okay, so we had said number 2. There's our solid, organized, compact for the carbon monoxide compound. Now B, we said, was the gas. So let's go ahead and look at our options. Okay, that's showing that we have the liquid. So space, disorganized. Let's keep going. This one. Okay, it's showing a gas. It's spread out, but it's not correct. Do you know why it's not correct? Is because it's not the compound carbon monoxide. I don't have the carbon and the oxygen touching each other. So again, that's another garbage. Here, garbage. It's not connected as a bonded carbon monoxide. There's our gas. There's our gas. Just for sake of argument, another garbage. Those are broken apart. That's trying to show a solid, but it's not solid carbon monoxide. Okay, so there's our gas as the carbon monoxide spread out, disorganized. Lastly, this is our liquid. C was our liquid at that negative 202. Okay, so garbage with a carbon and oxygen broken apart. And then number 2, that's showing a gas spread apart, random, and we do have the carbon monoxide, the carbon and oxygen bonded. There's our liquid. So we have some space and it's disorganized. Let's just look for good measure at number 4. Broken apart is not carbon monoxide, and that's showing a solid, organized, and compact. So our liquid is right there. Nice. For fun, let's go ahead and click check. I always like it when we get that green right there, correct. So proud of you. Good work. If you haven't already, please like and subscribe, and I'll see you next time.